All right, in this video, I'm sharing with you some strategies for what do we do when we divide things with exponents. Let's go back to our original example, 5 to the third. The old standby. Okay, this really does mean that we have equals, thank you. Eventually it'll draw an equal sign. There we go. You do this or else. Right, the exponent, the 3 exponent, trust me, that is a 3. When you have that, you are writing out the number of things that are there that many times. But what if we divide? Like, let's say we have 5 to the third, and we're dividing by 5 squared. The base, 5 and 5, they're the same. That's kind of one thing to keep in mind as it makes these things work together. On the bottom of this fraction, we're going to put 5 times 5. Now, get your cancellation pen going. When you have the same thing on top and bottom of a fraction, cancels, cancels. What are we left with? Just that 1 5, right? Now, if you write a 5 down, it does have an exponent, right? The exponent still is there. It's a 1. But we don't really need to write, don't write that. The point is that there's only just 1 there. So if we wanted to, the goal of this video is to look for a shortcut. We could have done 5 and cleverly combined the 3 and the 2 with subtraction. That subtraction step is what does it to let us know when we're dividing power, a base to an exponent divided by the same base to an exponent. Could be the same, could be different. We subtract the exponents. Let's try with another one. Let's go with x to the 4th divided by x squared. I don't like the 4 in this problem, nor do I like the 2. So, excuse me for a minute. Let's go x to the 6th divided by x to the 4th. I wanted that one because we've seen a lot of 3s and 2s combinations. Do you know what the shortcut is? That, right? So maybe pause this video, write the answer down. Oh, and then resume it, right? Here we go, back into it. So x times, that should be 6 x's. 1, 2, 3, 4, 5, 6. And on the bottom, 4 of them. Get your cancellation pen out. Cancels, 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 cancels. If they're multiplication on the top and bottom, then if they're the same thing, they reduce each other to 1. What we have left is those 2. But if you know the rule, right? If you know the rule, in this sort of scenario, we are able to subtract. So we have x to the 6 minus 4. It's always the top goes first and the bottom goes second. Let's try this with one more example where it's not as nice. Okay, let's go y to the 3rd divided by y to the 8th. Now, the shortcut, right? Let's do the shortcut. So 3 goes first. Y to the 3 minus 8. It's going to be negative, right? A small number subtracted by a bigger number means that the result will be negative. You could say you're done. Some people, we don't like to have a negative in front of our exponents. So we need to go one step further. Maybe the way to help explain this is to actually not use the trick for now. At one point, use the trick. Let's write this whole thing out. This equals, I'm going to write out the bottom first. There's so many of them. Y times 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 y. 8 of them. On the top, 3 of them. Get your cancellation pen out. Cancel, cancel, cancel. There's nothing on the top. Lies. There's always something left on the top. It is a 1. You will lose points if you leave the top blank. And on the bottom, 1, 2, 3, 4, 5 y's. So in other words, 1 over y to the 5th. These two things are the same. Whether you write a negative exponent or you write a flipped 1 over y to the positive 5 exponents, they are equal. That's a little more commonly accepted. This is still correct. Make your pick. Thank you for watching this video. There might be more. Stick around.